I'll first give an introduction about Antarctica, tell you a little bit about what it's like. We'll get into the observations from both points of view, from Earth and from space. We will talk about how those observations are being used in research today, including a little bit on weather forecasting. Become a very hot topic in the last couple of years in the Antarctic. And of course, everyone's interested in the climate. Is the climate changing? And we'll talk a little bit about how Antarctica plays a little bit of that role as well. And I have to talk a little bit about these icebergs. It's something that we don't typically do here, but have fallen into the last several years at the university, and so we want to mention that. And we want to mention something that's coming up on the horizon. We hope to participate in a meteorology experiment in the Antarctic, and so I'll tell you a little bit about that, give you a flavor for the future. And if we have time, we'll hopefully go through some slides. I have a few slides from a couple of my trips back about going down to the ice and what it's like to be down in Antarctica. And of course, we'll have time to answer your questions. So we'll begin with, of course, an introduction to the continent. It's a big place, 5.4 million square miles. That's about 1.5 times the size of the United States. It's the highest, driest, windiest, and coldest place on Earth. So there's your figures and facts for that. Makes a very challenging place to do business, without a doubt. And of course, it's been the last place on the Earth to be really heavily explored. It's the big exploration that took place in the late 1800s, and of course, in the beginning of the 1900s was when we had a lot of activity from the British, Scott, and Shackleton, and of course, Amundsen, who made it to the pole, South Pole first, and of course, the United States got involved with Richard Byrd, Admiral Byrd, getting into Little America and starting the U.S.'s exploration of the continent. And fortunately for, I think, everyone in the whole world, science very astutely decided in 1957, as a part of the International Geophysical Year, to study Antarctica special. And it is since then, and only a couple years later, an international treaty has been set up for Antarctica to preserve it for and save it for scientific research. And so since 1957 to present, the United States has had an Operation Deep Freeze. It's a joint military support for the U.S. scientists doing work in the Antarctic, including ourselves. And it's been a wonderful environment to be in this part of the world where all the nations cooperate very well doing the activities that we all do on that continent. Let's start with some observing from the ground. What are we doing? And obviously, the most logical place that we've started doing observations of Antarctica is from the stations that were set up, especially during those International Geophysical Year. Each of the various countries that participated in that year to do science, set up stations, and there are now, I think, many, many countries that have bases on the Antarctic, and they observe right from those stations. And of course, during the exploration time, they even took a lot of good weather records that have been used and kept around. And they do a lot of routine observations, a lot of aviation observations for flying planes in and out of the continent. That's a very common way to get down to Antarctica, especially for the United States. Ships and buoys is another one. Ships is actually the biggest way for most of the other countries to get down to the Antarctic. They take ships down when the ice is melted off. And there's summertime to go, and so ship observation is important. And lastly, but probably very critical, there's not too much of it, weather balloons. Very commonly used. There's only about maybe a dozen stations that do it, but they're very critical weather observations used in both forecasting as well as in research. And the United States started as the lead in about the very late 70s, realizing the need to do automatic weather stations. And so since the late 70s through the present, automatic weather stations have been probably the largest amount of observations taken from the ground of the Antarctic state. I have miscellaneous lists. There's always a special project that's set up to do a variety of other kinds of observations using high-tech equipment like lidars and sonars and such sort of thing. They're usually temporary, they have a permanent, they're not always there, but there is a grocery list of those as well. In 1980, we only had 9 automatic weather stations on the continent. Today, there's over 100. And here's a map of most of them that we can put onto the continent. All the ones that got little dots are the United States. The triangle ones here belong to the Australians. The Italians have an array in this region of the continent. There's a few that aren't listed here. The Germans have had a few up there, the Dutch. But for the most part, the United States, in cooperation with the Japanese, who operate in this part of the continent, with the French, who operate in this part of the continent, and the British, we have here at the University of Wisconsin been working with each of those countries to have the weather stations that we build and maintain here at the university put into these parts of the continent to do weather observing. And this is what the stations look like. Here's a fellow in the field actually working on one, and this is what the schematic of one's like. Very basic weather instrumentation on board these instruments. An aerovane to report wind speed and wind direction. We have temperature probes right at the top of the tower, and we actually, on several of them, have temperature probes at the top and the bottom of the tower, so we can get temperature difference between the top and bottom. Pressure gauge is actually put into the electronics enclosure. It's kept in there. In fact, it's our most expensive and most valuable piece of equipment because we need to get that pressure correct. It's really critical. And we've been adding quite recently relative humidity. And then we have an antenna that transmits this data up to whole orbiter satellite. In fact, it's one of the reasons that makes an automatic weather station a viable thing these days is that we have weather satellites in orbit that can receive data from these stations. Here's what they look like. I'll have you look over here a little bit. We brought a mock-up along tonight. This is not a brand new station. As you can see, it's beat up and it's been through quite a bit. But this is what one looks like. Aerovane, temperature probes, electronics enclosure with the pressure gauge inside. Here's what the relative humidity probe is like. That would be underneath the boom here. And in fact, I'll pass it around. You can actually take a look at this. And actually, it's a lot more exciting to be taking weather observations automatically rather than having you go on down and read a dial like this. Would you like to do that? Go on down and read the dial all year long and tell me what the weather is? Probably not. But in any case, this is, instead of doing this, we've had it all done electronically. We use platinum resistance thermometers. So instead of using a mercury or an alcohol-like thermometer that you might have out your kitchen window, we do it electronically. And doing electronically means we have to have power. As you can see, we have solar panels and gel cell batteries. These batteries get recharged by the sun, and they do a really good job for us in doing this weather station. Here, I'll pass the thermometer around too, so you can take a look at that. In some parts of the continent, this kind of aerovane does not work out. Some of the wind speeds can get very strong, and I'll talk a little bit about that later in the talk. So we have to instead employ some very heavy-duty technology. And I'll have you come on up and take a look at this. These are very heavy. That's the wind direction unit, and this would be the wind speed unit. These are built by a fellow in his garage here in the United States, and he's done a wonderful job. They're used in a lot of ski areas and in a lot of mountain areas in the country, and they're wonderful. But unfortunately, even Antarctica can be vicious. We went back to a station one year, and this is all we saw. It's all gone. It blew off completely. So it's a pretty rough place. The wind speeds can be very intense and can be very damaging. This station came from one of the windiest parts of the continent, and you'll come up and take a look. If you can see, the paint's been sandblasted off of the props, and this probably was one of the stations that we found lying on the ground when we got back to it. So these are a wonderful way to observe and not have to be there. We are planning to do a next generation station. This technology is wonderful. It was spec'd in the early 80s. It's the same technology that went on the Pioneer and Voyager spacecraft. Military spec, it does wonderful at very cold temperatures, but you can't buy it anymore. You can't find it anymore. And so we're going to be developing a new one. And I thought it was interesting to put a couple of points about our weather station as we've been redesigning our new one. Our current station uses a whopping 256 bytes of memory to do its counting and recording of data. Wow. That's it. That's all we have. And the new one, we're going to have more. We're going to go up to a whopping 16K. Wow! It's just phenomenal to think about how that was such a big number in 1980 when these things were designed, and yet nowadays it's nothing. Power. That station over there runs on one 60-watt light bulb for 1 hour, the entire year. So the 60-watt light bulb that's in your kitchen that's running for 1 hour is what will take to power that station for an entire year. It's a very simple device. It's basically spending time counting, taking observations, and transmitting them up to a satellite. Very low power. And the new station, we're going to do half that power for the same observing. So just to give you a couple of ideas of what we're really dealing with here. And it's really critical because that's why the low power allows us to put stations out there for a long period of time. They don't require a lot of battery power or a lot of solar power to run.
How does the 10 watts keep up with the 60?
10 watt solar panel?
Yeah.
We actually end up having the power is actually put into just recharging the gel cell batteries, and they're basically a 6-volt, 12-volt combination that actually power the station. So it's the same amount of power that you spend, and if you do a computation of how much power 60-watt light bulb is using in 1 hour, that's the same amount of power that the station uses in this configuration for the entire year.
Well, is that intermittent then? Is that only on part of the time? Or
no, the station's actually on all the time. It collects new information from all the sensors every 10 minutes. So, yep, they're on all the time. Now, in the part of the world where the Antarctica is, this is all the dots that could be possibly collecting weather observations, whether they be manned stations, aviation places, places where they land aircraft, or balloons, whatever. This is it. If I put a map of the United States, which would basically fit in this part of the Antarctica, it would be colored in. That's how much observing we do here in the United States, but how little we do down there. And this is only all the possible ones. There are a lot of them that don't report all the time, and not every hour. A lot of these are only every 6 hours, or every 3 hours. So obviously, space is the way to do it. And so we here at the University of Wisconsin have been, for the last just about 10 years, this October will be a 10th year anniversary of making these composite satellite pictures. We've been using satellites from geostationary and polar orbiting satellites combined together, like a jigsaw puzzle, we put it together. And it's been a great way to go, viewing the Earth. So let me show you a couple of montages here of satellites and their usage in the Antarctic. Of course, I have our composite. These are a couple of examples of infrared picture. So just as if you were looking at what's very bright white is very cold and what's dark is a little bit warmer. And water vapor. How many folks listen to watch the Weather Channel? We have a lot of folks who watch the Weather Channel. Do you see the water vapor pictures they have on the Weather Channel? We do the same thing in the Antarctic too. We can do that too. No problem. And it's really nice to see this because you can see a lot of the storms, a lot of their activity very clearly in a water vapor picture that you might not catch in an infrared. Before this, though, since even the 70s and 80s, the way to do satellites in the Antarctica was polar orbiter strips like this. Satellites that orbit from pole to pole every 100 minutes, take nice pictures, and they go by the poles often enough so that you get really good data. And that's been the bread and butter, if you will, for any meteorologist doing research, doing forecasting, has been these polar orbiter satellite strips. And in this case, remapping them into a constant projection over your area of interest so you can watch the weather patterns go by. Not much different than what you see on the TV here with the geostationary data in the mid-latitudes. And there's a lot of newer satellites taking polar orbiter data here. This is one example of a beautiful one from the Terra satellite that NASA has up. And it's been wonderful because we've been able to take this and make pictures of where we think there aren't clouds and things like that. It's been very exciting. Or even doing interesting things with the satellite data where we can derive what we think the surface temperatures are from satellite. Very interesting prospects. Yes?
Yeah, how accurate are those readings as opposed to the stations on the ground?
No, that's a good question. They're not perfect, that's for sure. They're not going to match. And then the satellite's ability to see right to the ground is not quite at the same level that these things are recording. So there's some differences, there's no doubt. But it's pretty good. It's better than, just having the few observations we have on the continent if you needed something very aerial.
So how many degrees off?
Oh, well, I haven't actually looked at that. That's a research project that's going on at the university here in Madison. And I think it's probably, I would say off the top of my head, it's got to be within a couple of degrees at the best. At the worst, I'm sure it can be off more than that. the Antarctic actually has very strange characteristics because the ground is so cold compared to the air above where we're even walking at. It can give you some really misreading information on either the satellite or even the weather station.
So what's the temperature of the ground and ice?
Well, the temperature of the ground and the ice can be, very cold, much below freezing, all the way down to zero. I haven't actually done a lot of studies below the ground myself because I study everything above that. So this morning it was 101 below one of our weather stations. So I'll give you an idea of what it's like this time of year. Other things we can do with the satellite data. One of them, as you can see, these two, we have lots of wind bars. You can actually use the satellites to derive where the clouds in the satellite pictures are and where they're going. So you can actually figure out what the winds are based on where the clouds are moving on satellite pictures as you animate them. So it's a very handy technique that was developed here at the University of Wisconsin, and now they're starting to apply it directly in the Antarctic. And this has been really valuable. It has great possibilities to give us a lot more information than just a couple of weather balloon observations that we have around the continent that would give us winds in the atmosphere. Now we have satellites that can tell us that information. I, of course, have been working on my own PhD research where we've been trying to look at fog in the Antarctic. It's their number one aviation problem. When you fly a plane there, fog is a big problem. It's huge. And so being able to find it, and this is one of my goals, is to try to be able to see if we can do that from a satellite so that we can warn pilots of that being out there. And of course, I had to show a couple of pictures of these big icebergs that happen to be around in the Arctic. And a great way to see those is from the satellite. So observing from the satellite is a great way to go. And of course, I have my nifty forward-leading continent picture. This is the kind of satellite picture that a weather forecaster would be handed. And actually, this is the newer satellites. They're not even get something quite this size. And you have to forecast it using data that looks like this. It's very complex. Polar plateau, lots of mountains, different kinds of clouds. This is actually a huge fog bank. Ice, open water. It's a real challenge to use this data. It takes quite a bit of training and a lot of experience to do that. Now, let's talk a little bit about the research using these observations. Neat picture of Mount Howe, which is far up onto the Antarctic plateau. We'll talk a little bit about katabatic winds and polar lows. These are two very interesting phenomena, almost unique but not quite unique to the Antarctic. There's a lot more than we probably have time this evening to talk about. First I'd like to mention is these katabatic winds. And this is a wonderful picture that was put together by some folks at Ohio State University. And you see these very interesting dark streaks on the satellite picture. This is a thermal picture. So the dark is very warm, or relatively warm. And the bright white is where it's very cold. This is a high polar plateau. And this might be my good one-time lesson for the evening. If I have a mountaintop and I put a ball on top, what will happen to the ball? Going to stay on top, or will it fall off? It'll fall off. Now, as the ball goes down the hill, will it go slower and slower or faster and faster?
Slower and slower.
It'll go slower and slower as it goes downhill, or will it roll faster and faster as it goes downhill? Does everyone agree with that?
Picture is too great, it'll accelerate.
Faster and faster? Okay, is everyone like that? Faster and faster? You're right. It'll go faster and faster. Cold air that forms over the high polar plateau of the Antarctic does the exact same thing. It's very heavy and not very stable like that ball on top of the hill. And it falls down the glacial passes between the mountains along the transantarctic mountains that are here that kind of a barrier between the high polar plateau and this lower ice shelf. And as that cold air goes downhill, it goes faster and faster. And it warms up, relatively speaking. So that, here's a great example. These are weather station temperatures that are plotted on this picture. And you can see the temperatures warm up. 45 below, 39 below, 27 below. That's only in just, 50, 60 miles. Not a very, very short distance, rapid warm up of that air as it goes down that hill. And it speeds up, 10, 20, 45 miles per hour. Some of the winds from these katabatic winds, this is what they're called, can be as much as 129 miles an hour like that station's experienced. And how that's why our weather stations get beat up so bad. The winds can be very intense. And so intense that they show up very well in satellite data. And that's what you're seeing here. All these katabatic winds are funneling together into this big airstream that comes off the Antarctica. So very interesting stuff that takes place in the Antarctica.
So wind goes faster, it heats, temperature rises?
Yeah, as air goes down, it compresses when it goes downhill and it warms up. But it doesn't warm up a whole lot, does it? Minus 80 to minus 40 isn't exactly a big warm up. It is in the Antarctic, sure. Another interesting phenomenon, and this is something we observe from the surface. Weather stations are wonderful in picking this up. Little low pressure areas, little ones. You know, like we have big ones here in the United States. They take up what, half the United States? Several states big. These are little. They would be like a little one between, say, Madison and Milwaukee. And they're very intense when they get going. So if you're wanting to fly into the United States' main base, main station here at McMurdo, and you have a little one of these form, boy, it's horrible to fly through. It's extremely bumpy in that aircraft, bouncing around in the really strong little winds and these little polar low systems. And it turns out that the most of them occur right here, right by the United States' main base. We picked a wonderful place to pick a station. It has some of the worst polar low activity on average over, as you can see in this map here, 5 to 6 a year form in this part of the continent, more than anywhere else in the world. Yes?
Is that wind speed around there, 84 or whatever, is that the wind speed?
These are actually isobars. They're lines of constant pressure. So he's the meteorologist who did this analysis dropped in leading 9, and it's in millibars. Most meteorologists love to talk about the pressure in millibars rather than inches of mercury like you all hear on the TV. But it's got a conversion, so that's what you're seeing there. Yeah. The wind speeds are in these flags here. And as you can see, as you get into the center of these low pressure areas, they get very strong, 40 miles per hour, very intense, where they're very calm on the outside, 15, 10, very much calm winds on the outside of those winds.
Do those pressure systems move, or are they just stationary?
No, they when they start forming, they may stay stationary in this area during formation, but once they get going, then they do eventually move, yes. And that's the problem, is that their movement is almost as hard as forecasting for hurricane. It's the same kind of thing. You pretty compact storm that you've got to figure out where's it going to go. And a lot of big influences around it push it around. Very challenging to forecast for. I don't envy the weather forecasters who have to do this on a daily basis.
What generates these? I mean, it's not upper level winds, I'm assuming, or is it?
If you can answer that question, you can be a very rich man. That's something we're trying to figure out. And that's one of the things we're going to be doing in the future. So, I have a neat slide here of Captain Scott's hut. It's really interesting. I've had the pleasure of going inside his hut, and there's all his gear. Even the sides of the boxes that he had are stamped with his expedition on it. Forecasting with a computer. And I'm going to throw up here a series of people and countries that are working on using the computer to do weather forecasting. The United States, of course, has really gotten into it in the last several years. Here at the University of Wisconsin, we've used this modeling system that we've developed to do some examples, and I'll show a little of that. And then, of course, I'll show the one that's become one that the U.S. has done a lot of work with. It's a polar model that it's spent time with. But we're not alone. British, French, the Germans, the Australians, and even some engineering guys are trying to get something interesting. I'll show that too. It's really the way to go. We have a lot of satellite information to put together with these weather stations.
Where are the Russians?
I'm sorry, what's this?
Where are the Russians?
Where are the
I
Russians?
haven't heard anything.
You know, that's very interesting. The Russians really have not been putting a lot into the Antarctic continent since the collapse of the Soviet Union and the switch to the Federation. In fact, they've actually given up one of their stations. Actually, I shouldn't say that. They've actually closed several of their stations. They used to have many, many stations around the continent. Yeah, if you go around the Antarctic continent, the Russians have all sorts. And they have since closed several because they're not financially able to keep them open. Good question, actually. This might be, if you were a weather forecaster, you would get for a weather chart from a computer model these days. It might look like this. This one shows where it's moist, nice and green, where it's dry, it's nice and white, and it might have wind bars. That's an example chart. And this is what we're using these days to do. Starting to get into it. How good is this stuff? How good is a computer simulation of the weather? I mean, I know it takes these observations and it kind of churns through the computer and you get out. And I have these charts here that compare what the computer says to what that weather station says. And the lines that you see on here are pretty good. They line up pretty well. They're not perfect. They don't exactly match. In fact, some places I'm really disappointed they don't match at all. The dashed lines, if you can see the dashed lines are the observations. The solid straight line is the computer. Not bad, but it's got ways to go. This is not very good forecast compared to what you could get here in the latitudes. It's not that same quality. It's getting there though. We can actually start talking about this. We're at the point where we're only maybe 20 or 30 years behind what you guys are used to here at home in Madison, Wisconsin. But that's where we're at, and that's what we're trying to get to. Here at the university, when we did computer modeling, we took weather station data from a bunch of weather stations around a particular area where the U.S.'s main base is. And the U.S.'s main base is near a very tall set of mountains. In fact, this is a tall island, Ross Island, where the station is located. And we actually simulated the airflow. These funny lines, these squiggly lines, are airflow around this obstacle. In fact, if you look down on it, you can see the air goes and splits around this big obstacle. And actually, it's very important for an aircraft, if you're going to be a pilot flying through these, you want to know about them. You don't want to accidentally turn into some really turbulent air and lose lift in that airplane. So we've actually done some of these simulations in our group. It's been really interesting to learn about these kinds of activities that do take place, that pilots have said, you come back and said, oh boy, that was a bumpy flight, and now we know why. The engineers are starting to get interested in this too a little bit. This is a very unique weather model where they actually wanted to simulate this part of the Antarctic Peninsula. Here's the Antarctic Peninsula here. It's this big part that sticks out. And it's kind of like a barrier. It's something that just sticks up out of on either side of the ocean. And so you get some very strange weather phenomena that takes place, and there's a few folks that are starting to look at modeling that on a computer as well. But basically, for weather forecasting, for many years it was rules of thumb. In fact, I actually found this Naval Support Force Antarctica Handbook of Meteorology, their forecaster's handbook, that was in a waste paper basket. And I rescued it because this is really neat. It's full of all these rules of thumb, all these little basic things that experienced naval officers over time during their tours of duty learned, wrote down, and passed on to the next forecast. Since that time, the international community has gotten together and written a detailed forecast book. It's updated, it's got great documentation, all the science. And we've moved a lot along, because this is what it was like when I first started, when I found this was, last revision was at 1990. This came out just after 2000, 2001. So we're making a lot of progress. Someday we'll be able to talk about weather forecasting in the Arctic, just like we talk about weather forecasting here in the United States. Pretty good, 24 to 48 hours, not too bad. Nowadays, 48-hour forecast in Antarctica is not much different than your 5-day forecast. You kind of laugh at it and go, yeah, sure, it'll be like that. And it may or may not be. I'll stop here. Questions? Yes?
What sort of sensor do you use to measure humidity in such low temperatures?
Yeah. Humidity measurements, we use a Vaisala HMP35A sensor. Humidity sensors are lousy, period. I don't care what kind you have. They're not very good. They have a large error associated with them. So we do what we can, and we found this one to be not bad, but we've not been able to compare it very well with some other kind of observation to corroborate it at the very dry locations in Antarctica. You know, the coastline, where you're close to the ocean, there's a lot of moisture running around. It's not that bad, and that's where we have most of them. The tough parts are South Pole, on the high polar plateau. Now we're in a very dry part of the continent, and there, I don't know, we really can't tell you how good it is.
What sort of principle does it work on? Is it,
Some of them are based on a carbon sensor that actually react to the humidity.
so it's basically an electrical change in the sensor due to absorption.
Right. All of the sensors are based on some sort of voltage or electrical change. And that's
So
all that thing does, is record the changes in the voltage as they go by.
So what's the dew point like the South Pole now?
Dew points? Oh, well, if your temperature is only, well, see, this morning I checked and it was about 60 below. So your dew points are going to be on the order of 10, 20, 30, 40 degrees below that, to the point of it's not bother recording it.
Even that cooling would work good down there.
Yeah, really, it would. Any other questions before I go on to climate stuff? Yes?
How come the Russian ship got froze in?
With all the weather forecasting stuff that's down there, how come they got those in?
Okay, let's fill in everyone on what you're asking about. Recently, the Russians who have a station, one of the active stations they have left is up here, and this is near the Greenwich Meridian part of the Antarctic. They contracted a German ship to take their scientists from the past field season off the continent, sail them north. And they got stuck in the ice. And so now they're trying to figure out how to get them unstuck. In fact, apparently what they did is, this is very interesting. Let's see how many countries we can get involved with. German ship taking out Russian scientists, and they have the South Africans bring 2 helicopters to put on an Argentinian icebreaker that heloed off. They literally took the helicopter and flew off all the scientists off to the South African ship to send them north so that they could get rescued. And the Argentinian ship, as we speak, should be in the middle of cutting ice around that ship to make it go, get unstuck, if you will. As far as I know, the Swedish also sent an icebreaker, and it could be on its way. I don't know the exact status of that. I don't know why they got stuck in the ice like they did. That's a good question. I don't know. When you get into weather, you know, we're caring about the atmosphere and the temperatures and the winds and that sort of thing. Sea ice is another ballpark, and why they got stuck in that, I don't know. There is a lot of ways of looking at sea ice from satellite, and it's something that we don't do in our group here at the university, but there are those who do. And yeah, they really got stuck because this is expensive. It's great to see international cooperation. It's not often you're going to get those really diverse countries to have to cooperate. But in the Antarctic, it happens more often than you realize. And it's wonderful because it's probably the only way people could ever function down there. But yeah, they're in trouble right here. It's the 3rd year in a row we've had to rescue people off the continent. Last 2 years we had to do what, the doctors at South Pole?
Yeah.
It's the 3rd year in a row we've had to rescue people. Pretty scary. Any other questions?
Yeah, I heard like some kind of a western ice sheet might break off, talking about the pool. Where's that?
Well, let's look at the climate part. We'll see if it answers your question.
All right.
This is a really neat one, speaking of things. This is the Larsen ice shelf, taken by the Argentinians. And you'll notice that this is what the edge of an ice shelf looks like. Water right up to a cliff. And it's a pretty decent one, too. We're talking, 20, 50 feet tall, roughly. And you'll notice there's a big waterfall of water coming off of it. Now, this is this part of Antarctica right here. Keep that in mind for later in the talk, and I'll show you what happened to this ice shelf. Climate research. Sea ice edge. Everyone heard of El Nino? How many people have heard of El Nino? A whole bunch of you? Yeah, okay. Well, it shows up in Antarctica too, folks. And yeah, we can show it in a couple of ways, not only in the sea ice edge activities, but it shows up in the precipitation and evaporation. And it shows up in the temperature and in the pressure that we get on the weather stations. So these are 3 nifty charts I wanted to show you. And there's a lot more. This is just the beginning. We're still learning about, we've just now been observing Antarctica long enough to start talking about the climate there and its relationship to climate in the rest of the world. So this one here, I've got these neat pictures that are from Lamont Doherty, Columbia University. Miss Wine does a wonderful job. You'll see in this part of Antarctica, this is this one sector of the continent. We're looking at this piece here, this section here. Out over the ocean, you'll see here this white line and this blue bullseye. That white line is the average growth of ice in the wintertime out from the continent. So that's way off the bottom of my map here. And this blue area is where it has the most variability. It's a bullseye right about here. The rest of the continent doesn't have that amount of variability to that degree. And it varies the most between El Nino and La Nina years. That is, years when we have an El Nino and years that we don't, or we have the opposite condition. And temperature as well in that part of the ocean has big variations, as you would expect. If you've got sea ice there, it's going to be colder than if you don't have sea ice and you just have water. Big, big changes, and it's very noticeable. In the same part of the Antarctic, not here, but right over the western part of the continent that you were talking about, the amount of precipitation versus, so that's the amount of stuff that's actually falling out of the sky, snow, not much rain, but mostly snow, versus evaporation, that is all the moisture coming off the continent getting into the clouds. When you take the difference of those two, it's amazing how much it looks like this black line is El Nino, basically. Southern Oscillation Index is El Nino. And it looks almost the same up to 1980. Look at that. These lines follow each other very well. And then after 1990, they are opposite each other. When it's low, it's high. There's definitely a relationship here. It's extremely strong relationship between El Nino and this part of the. It precipitates a lot here, a lot of snow accumulation that takes place here. And it's very interesting that it switches sign, right? Highly related, and it's highly anti-related. Wow. We don't know why. We're still looking at it. All of us who do Antarctic science, not just at our institution, but others. If anyone can solve it, we're interested. We'd love to find out. We don't know. And of course, our own weather stations alone have discovered that we can really see an El Nino event go by. This is the big one, 1980, 82, 83. This was the big one that we all first heard about, this thing called El Nino. This is when it first made news in the United States. And if you look at these charts, this is the number of times the temperature was in the 5-degree range, 10 degree, 15 degree below, etc. And you see in 1981 that it peaked here, most of them were about -20. And then in 1982, the peak shifted. This red shift down here, it shows that the peak is now down to about -25, -30. Much colder, dramatically colder. And then, of course, in 83, you can see it warm back up again. The peak of green is a little further to -20, -15 again. Very dramatic. And only in this part of the continent. This is a weather station located right here, not about more than 20, 30 miles away from McMurdo, the main U.S. base. Right? This part of the Antarctic has a strong relationship to El Nino. And it's well agreed upon by all of us meteorologists studying this part of the continent that this was taking place. So it does have a big impact, without a doubt. Now we have to talk about icebergs. It's something that's funny I've never really gotten into, but we tripped into this, and so before we get into it too much, I thought I would show you how icebergs are named. How come they aren't named Big Bertha? You know, I always wondered that. Well, it turns out that in the United States, the National Ice Center, or used to be known as the Joint Navy and NOAA Ice Center, it's now the National Ice Center. They've come up with a naming convention. They split Antarctica in 4 parts, just like that, and it's labeled the parts A, B, C, D, or the quadrants. And then every time there's a calving of a 10 nautical mile or bigger iceberg, they'll track it. That's their job. And so if you look at this one here, A38, it's the A sector is where the iceberg calved from, and it's the 38th iceberg in that sector that we follow. And I've labeled some of the ones that I'm going to talk about a little bit. A38, A44, B15, B17, those are big ones that we hear in Wisconsin. C16, C18, C19, and I am going to talk a little bit about the Larsen ice shelf. There are other ways that ice comes off the Antarctic continent other than making an iceberg. Does other things, like collapsing. And that's actually how we got into this business. And it used to be a hobby for us. I'm having this weather satellite data. I'm usually busy looking at these clouds in this picture. But, you know, look at this big piece of ice that's sitting out there. Boy, you can't miss that. And that's actually, this is a 1995 picture with the Larsen Ice Shelf A. So this is the Antarctic Peninsula here. The Larsen Ice Shelf is right along the Antarctic Peninsula. The A part of the south, the northernmost part of the shelf, collapsed. And actually there was some icebergs out of it. This was one of the little ones. In March of 2002, this is where Larsen Ice Shelf A used to be. And this is Larsen Ice Shelf B. See that all dark? It's not nice flat gray like this part of the picture, but notice it's kind of dark. Well, it's because all of that ice is now like ice cubes in your glass of water. It's full with water now all of a sudden. This is just the picture I had here at Wisconsin. It's not the best one. The best ones that I saw came from that new Terra satellite, that new NASA satellite. Here's what it looked like before January. Here's the Larsen Ice Shelf. You can see some of these gray speckly things on it, but look what happened in less than 5 weeks. Wow. It's almost like someone took that ice shelf and broke it like a mirror or a piece of glass, and it shattered thousands of little pieces in a very rapid amount of time. So the Larsen Ice Shelf B has completely collapsed and has now made a big series of little tiny icebergs. I guess the theory is that you get these melt ponds on the top of the ice shelf. And ice shelves are not a big solid piece of ice. They have all kinds of cracks in them. And the cracks are filled with air and snow. Well, air and snow is a wonderful insulator. It keeps the ice shelf frozen. But if they get water on top of them and those cracks fill up with water, wow, now you have a problem where it starts to eat away the ice shelf. And it's apparently, in the cases here where you've got lots of melt ponds that go way into the ice shelf, you're basically at a catastrophic point, and the ice shelf collapses completely. So this is the other way of losing ice from the continent, rather than big icebergs. You lose it this way. So there goes a neighborhood. So I have to admit, I'll have to tell you a story later about how this picture is both funny and actually very sad at the same time. So we've gotten into observing both from the ground and from satellite. In fact, this is a weather station that we've put on an iceberg. It's a great way to go. And so, as I said, we first started following icebergs as a hobby. Here's another one. This is 838 A and B icebergs that we first saw. I was interested in this low pressure area. Look at these beautiful clouds here. I was excited about that. And my guys are telling me, hey, look at this. There's a big piece of ice in this picture. And sure enough, in March of 2000, we happened to meet. I met Professor Doug McHale at the University of Chicago, and we were talking about that other iceberg, 838. He saw my hobby pictures of it, and he had all the computer simulations of it because he's a glaciologist. He studies ice and icebergs. And we were collaborating on that, and he showed me this picture. He says, hey, take a look what the weather forecasters in Antarctica at McMurdo Station first saw this picture. Do you have these pictures in any of your weather satellite data? And they said, sure, I got a whole bunch. And so I made this picture, and it got onto the web and into the newspapers and the radio, and oh my goodness, I spent 3 weeks talking to the press. It was great. And it was very exciting to follow these icebergs because they did neat things. It broke into 2 pieces. And just like a bull in a china shop, it backed up at one point and broke off another big piece of ice. Now this is large pieces of ice. This here is like driving from Milwaukee, past Madison, past Dubuque, to 60 miles west of Dubuque. That's how far that piece of ice is. And it's just like going from the Wisconsin-Illinois border to about Whitewater Plateau. That's the area we're talking about. Big, big, big pieces. Now this part of the Antarctic, this Ross Ice Shelf, hasn't capped icebergs this big in about 50 years. And actually, I guess the theory that the glaciologists tell me every 50 to 100 years, these ice shelves, there's 2 big ones in the Antarctic, Ross Ice Shelf, Ronnie Ice Shelf, to maintain themselves have to do this every 50 to 100 years if they're going to keep their shape and their sized area. So this is not a global warming phenomenon.
A lot of people think it was.
That's right, a lot did, and that's very unfortunate. In fact, we're very fortunate only 2 of all the media outlets that I ever talked with or ever reported on it did say that, oh yeah, global warming. And of course that's not true. This is a natural phenomenon that's overdue. In fact, if I drew for you, we have a map of the front, the ice front where it used to be. Navy spent a lot of time marking that up one year, maybe 20, 30 years ago. You'd be back here. This ice shelf has been growing out into the Pacific Ocean at about half a mile a year. And it's been doing that for quite a long time, since we've been studying the Antarctic since International Geophysical Year, 57. So that's about 50 years, roughly. And it's been growing out and growing out. It's going to eventually do this. And so it did neat stuff. At the same time, on the other part of the continent, where A38 broke off, which is up here off the top of the picture, the rest of that ice shelf broke off. And in fact, we were excited because we had a weather station within 17 kilometers of that break. We were really close to getting a weather station on an iceberg. Really close. And see, look, here's the old ice front. I actually drew the one in here. It's what the Navy thought it was back, like I said, 20, 30 years ago. And see how much it grew out, and then eventually broke off. So, these are exciting.
How far out is that? Like,
This space here,
yeah.
this space here is probably, this was brand new. It was only about 2 days after it broke off. And that's probably only I just showed you. It's about the same. It's about 20 kilometers, or 20. It's about that distance. From going from Illinois border to about Whitewater Plateau. It's about that distance. That's all that is. It's very interesting. These tabular icebergs have these very common shapes, no matter which ice shelf it breaks through.
So you can look for that every 50 years?
Potentially, yeah. We don't really know because we've only had satellites for 40. And when the first weather satellites went up in the 60s, they were terribly coarse. We couldn't see details like that. And so only good observing took place from the 1970s on, mid-70s on. So we haven't been observing long enough. In fact, I think we're just sitting in the right time and place in history with the right camera, the right platform. Satellite. Great way to look at this stuff.
So there's more big icebergs now, right? Than
There have been in the last, yes, there are more
Because I
now
know
than.
one guy went on a trip down to Antarctica on a Russian supply ship, and he said it was, you know, the captain said it was like bigger icebergs than we've seen before and stuff.
Yeah, I don't know. I think that there have been about.
That was a few years ago.
So anyways, I of course like this picture because it shows this really neat weather storm in it. Nice and circular. And then of course it's interesting to see, look at this iceberg here, the B-15A. Wow, it's getting really close to here, just like a bull in a china shop. It hits that, and voila, it breaks off a piece. Chink. This piece of ice broke over here and actually had broken a 3 little pieces. That's C-16. What a mess, break off one iceberg and it creates tons of others. In fact, I like showing this. This is the weather station. This little arrow is the wind direction, and it's tracing out the path that the weather station took. So we've actually put GPSs on those weather stations. And you can actually see that iceberg moving. This is what it did from, this is what, January of 2001, and you're looking at this all the way through, till I think it's to the end of 2001. What that iceberg did. You can see it moving around. There's all these interesting things. It's the first time we've ever been able to get direct observations of what really big icebergs do. You know, a lot of meteorology books, they have a discussion about how icebergs move and this sort of stuff, and we can throw that in the bucket and we can learn how it's really done, because big ones behave very differently than little ones. I like this one too because it also shows some of the fast ice. This is the sea ice that gets in the way of ships too, a little bit, breaking away from the continent, and you can see this moving around a little bit too. This was a really critical thing for the United States because they had to send 2 icebreakers this past year to cut ice to get into McMurdo. McMurdo's down here at the corner of the screen. They had to worry about all this ice. It was a big problem. I like this overflight photo because it gives you some sense. This is taken from a C-130 plane flying into McMurdo. Here's a little island, Beaufort Island. And there's C-16. And this is this collision zone between the two of them, bumping into each other. And here's B-15. You can see what it looks like on the horizon. So, you know, you're looking at something, you know, bigger than LA, bigger than New York, bigger than Chicago. That kind of expanse is what you're seeing. And here's an example of us putting up a weather station on C-16. We have real-time data from this on our website. Actually, all of our weather stations are on the web. You can actually look at the data for most of them. And here is a recent picture. It's July 2. This is what's going on right now. Oh yeah, look at this. Another piece broke off. C-19 and little piece C-18. And it's been moving away and pushing right along B-15A. Here's McMurdo, right located right here. And actually, it's very interesting to see how this fast ice form. Once again, the icebreakers are going to have a hard time this upcoming year. They're going to cut the chin. And these are all temperatures. I apologize, they're in degrees Celsius, but basically minus 40 degrees Celsius is the same in Fahrenheit. So you can see it's very cold in the Antarctic right now, as it should be. It's time of year. So.
Do people fly in and out of McMurdo in that this time of year?
Yeah, they do. In fact, this is McMurdo right here. Oh, not this time. Not at this time of year, no. That's right. They only fly in from, well, they do fly in August, and then usually it's late September through mid-February, and that's it. Then the weather is just too much, and they don't fly in.
Is it the temperature?
Mostly temperature and station operations are hard to really keep up during the transition seasons.
So jets and stuff don't work too well when it gets
Yeah, the
cold.
C-130, when it gets really cold, the hydraulics become an issue.
Well, wasn't it when they rescued that doctor?
Yes, it was, and that's why they chose a Twin Otter aircraft to go get that doctor rather than a C-130, because the hydraulics aren't an issue, or much of an issue, on the Twin Otter aircraft over a C-130 cargo plane. The hydraulics would not
When
be
they
an issue.
hit the ground, they didn't want to sit there long.
They didn't.
It was too cold.
No, they didn't. They didn't sit there very long at all. Usually when the planes fly into South Pole, even during the summertime, they don't turn them off. C-130 stay running. They stay running for about a half hour. They have time to load off the cargo and people, put on new people and new cargo, take back off and go back to here. Here's McMurdo, a little hut here, Hut Point Peninsula, and here's the station, and here's the runway. Or one of the runways, it's actually 3.
I had a friend that flew one of those C-130s.
Oh, yeah?
He made one trip down there and he threw up his hand and said, "It's enough of this crap. I ain't never doing it."
It's a challenge, without a doubt. Well, the reason I brought this as a neat picture to show up, we've realized we have to do a little more experimentation. We need to learn a little bit about how these things work in the Antarctic weather systems, I guess, everything. The processes that make fall, that cause these really polar waves. And we need to study it in both these tiny little scales where the planes are landing and the big scales where they're flying through. And so we're going to do this experiment, and it's going to be a couple of intensive observing periods in the field season. And I've been pleasure to be part of the committees of folks here in the United States that have been working together to put this program together. And we're hoping over the decade, this current decade, to do this project and actually learn a little bit more about the meteorology so that we can make the weather forecasting move forward. And then when we're done, then we can talk about the climatology. That'll be the next thing. And this is how we're going to do it. Space and the ground. And here's all those miscellaneous neat high-tech toys that I told you about that we'd like to put into observing. You know, LiDARs and special snow gauges and all-sky cameras that look up. And we want special instrumented C-130s to go flying around in. Of course, more weather stations, more weather balloons. That's what a radio sun is. So we're really looking forward to that prospect. And of course, we're looking forward to doing it from space. Using, once again, these polar rear satellites, the brand new series that the United States is going to have coming online in the next 5 to 10 years. We're going to have a brand new series. We're going to use those. And of course, the geostationary platforms, the ones that are already in the planet, the ones that you see on TV weather. And I'm actually very excited about the prospect of having a satellite that's underneath the Earth, looking up at the South Pole. So we'd see this image. Wow, what a great possibility. We're actually now in the science community starting to talk about this as being a realistic possibility.
How does that work?
What kind of orbit is that?
This is a non-Keplerian orbit. It's a solar sail satellite. And some fellow at the University of Glasgow has figured out how to do this at these locations. And it is being researched by NOAA. And I'm looking forward to the possibilities that we'll talk seriously about this as being a viable platform for communications. Communications to South Pole is a big problem right now. Trying to pipe in a lot of science data that goes back and forth. And being able to do meteorology instrumentation, because if you can put a little camera on it, oh boy, I can see this all the time. And not just every 100 minutes, you know, or every 3 hours. When I make my composite pictures, I can only do that every 3 hours. I have to wait, collect all the data, and put it together. I could do it every 15 minutes. Wow. What a possibility. So I don't know if these will all be available for this meteorology experiment, but that would be really nice. So anyways, I'll stop here, leave my email address up on the website, and take any other questions before I don't know if we have time to run off to a slideshow, but
We're going to show us your...
yeah. Please, go
When
ahead.
you had that divided in quadrants,
Yes.
well, in D section, there aren't any ice-proof breaking off?
There are. It's just that our group hasn't been following any in that particular sector. There are. In fact, there was one that recently calved off this past spring. It was called D17, and I can't remember its exact location, but there's obviously been 17 of them in that quadrant that have been followed by the National Ice Center since the mid-70s. There isn't as much activity here because there isn't many ice shelves here. There's the Emery Ice Shelf and a few little ones, but there isn't as much as big ice shelves in the Ross Sea, or actually the most active iceberg calving part is the Liddell Sea here. In fact, this is one of the things that made Shackleton's trip to Antarctica, right? Shackleton took the Endurance to here and got stuck. There's excessively icy plains. It's a horrible place to go sail on a ship. It's actually a lot easier to get to here. In fact, this is the southernmost place in the world you can sail to. That's the southernmost spot. This is a tough spot to do because it gets very icy here and there's a lot of iceberg calving.
What's SODAR?
SODAR is when you use sound waves as an instrument to sound up through the atmosphere, and it gives you temperature and wind profile in return because sound changes as it gets affected by temperature through the atmosphere. So yeah, SODAR is something that they've fiddled with to do that. I don't know if it's a very clean instrument to use, but it's one of a host of ones.
Is it high frequency sound or low or?
Yeah, I think it's high, and I'm not really sure because I've never played with it myself. So it's a good question. Does anyone else have anything else they'd like to ask? Yes.
How about climate change with whatever these studies are, anything tie in?
Okay, I get my chance to have my public statement around. Wisconsin State Journal published an editorial a couple months ago about, oh yeah, global warming is just a theory. And they quoted 2 results from Antarctica. One is the dry valleys, which are these special climate, little areas in Antarctica. There's these dry valleys in between these mountains in this part of Antarctica. They have weather stations a lot like that. And the temperature there is getting cooler since they've been doing it. And the other thing that they quoted is that there's some guys who've been using satellites to study the thickness of this ice sheet. And they say, oh, it looks like it's getting a little thicker. So the immediate conclusion is, oh yeah, there's no global warming. Well, I don't agree. And I'm not saying that there is global warming going on, but what I will say is this. This is a special microclimate. It's unique. The only other place that's like this is like Mars. Okay? In fact, they actually like to study the dry valleys as a simulation for what Mars is like, weather-wise. It's not a representation of this continent. No way. I would never use that. That's a horrible point to do. The next thing, okay, so this is getting a little bit thicker. That means it's snowing a little bit more to make it thicker. How am I going to put more water in the air? Oh, I have to warm it up. That's the only way you can have more. In fact, that's why there's a lot more moisture in the tropics than there are in the poles, because it's that much warmer. You can hold that much more water in the air. So I would counteract that argument and say, wait a minute, if it's growing thicker, therefore there's more precipitation, therefore it's going to be warmer. So I disagree. The only place that those of us who study Antarctic meteorology will agree, the Antarctic Peninsula, this square area here, is indeed warming. British scientists, this is where the British have most of their manned bases, they have several, plus our weather stations and theirs. It's gone up about 2.5 degrees Celsius from World War II to the 1970s. No doubt about it. So we definitely have, in fact, that's a lot of reason why the Arctic ice shelf. In fact, we have a weather station on Ice and Ice Shelf C. Arctic ice shelf C is expected to collapse like being. And so it's very likely that this part of the continent is experiencing some sort of warming. Is that a sign of the global one? I don't know. Maybe. But we can say regionally, this part of the continent is truly warming up.
Okay, I heard Flato, I heard some scientists from Princeton, he said the western Antarctica or something like melt or drop in and could cause a sea level rise.
Right. There's a huge research project as a part of the United States Antarctic program studying the West Antarctic ice sheet. And they've been trying to determine with these ice streams and these icebergs and all this stuff, is this part of the continent melting away? It isn't as big or thick as an ice sheet as the East Antarctic ice sheet, but like the West one is. And I don't know that they've come up to a conclusion of saying, yes, it's collapsing. I can say that it appears that this section, Pine Island Bay, this one area, is rapidly losing. They're having iceberg calvings here and all kinds of things are happening. B-22, it made the news this past spring. This is where that formed. And so, yes, there's definitely something happening here. But the rest of the ice sheet, it's not clear to me, in listening to the glaciologists talk about it, that it is collapsing. Sure, this is the more sensitive ice shelf on the continent compared to this one. And yes, if it were to melt away, it would contribute, because all this ice is above land, it would contribute to ocean level rise. So I just don't know how rapidly we're losing it.
Yeah, the guy had said it's not sure that it'll do that, but if we keep going like we are, more CO2 in the air, we might increase the probability that something like that might happen.
That's the current premise, yes. Shall we do slides?
Yeah.
Let's go ahead.
Go ahead, I'll put the
Sure.
slides back.
Sure, sounds good. Go ahead to the next picture. This is my side there. This is where my journey begins. I fly 24 hours, and of course it's 2 days because you cross the date line from Madison to Christchurch, New Zealand. This is the International Antarctic Center where the United States, the New Zealand, Italian programs jointly start their projects or their journey down. This is where their logistical support is. So here I've issued all of my cold weather gear and so forth. We'll talk about that in a minute. And this is the way to go. C-130. In fact, it's not just a C-130, it's an LC-130. This is the way to go. And I have to admit, I've had some of my smoothest plane flights in the world on this. Because in the polar atmosphere, it's just not that bumpy most of the time, so it's real good. And here's an example of those skis put to use. They lower them down to land on the snow. This is at Williams Field. It's a ski ray. It's outside McMurdo. And this is why we take these planes. It's a great way to go. How many of you have been on a plane? Everyone been on a plane here? Okay. Does this what the plane looks like on the inside? No, I bet you don't. And jump seats. You can see all the guts of the plane. There's a couple of guys sleeping in the background. Actually, this is a nice flight because we're not all sitting right next to each other with our knees and are locked between each other. And you'll notice I've got my cold weather gear on.
Plenty of wood.
And I've got some of the, we had to do, we did work in Greenland at one time, and so we have some cold weather gear here. It's not the exact same kind we have there, but same boots anyways. I'll pass these around. This is what we get issued for boots. You'll notice they have an air valve in them too, so that you keep the air going in and out of them when you're in the plane, but you close them up when you're out in the snow so you don't get water in them. They're big, heavy-duty rubber boots, but they're a wonderful job at keeping your feet warm. So you're welcome to look at the cold weather gear later on after we're done talking. On my first trip down, I actually got to sit next to a porthole in the C-130. And this is my first picture I took over the continent. This is North Victoria Land, right here. It's a mountainous place where the planes fly to go into McMurdo. What do you see in that picture? Very, very much, okay, if you flip, flip the switch and go back on, flip the switch back. So these mountains are incredibly tall, but they don't look very tall in this picture, do they? That's because they're filled, all the valleys between the mountains are filled with snow. All these valleys in here, they're all filled with snow. So you can see a lot of the sharp peaks that would be there. They'd be like the Rocky Mountains, but they're all those valleys are filled with snow. It's impressive. And when I get off the plane, this is what greets me, the big terror bus. These tires are about as tall as me, so they're pretty, I got lots of grip running around in the snow and so forth.
You got pavement in Antarctica?
No, as you can see, it's all dirt and rocks, volcanic rock. Sprites, this is another way that they used to do a lot of travel around the continent. Track vehicles go over anything in these things. They're loud. And actually, that's one thing that's interesting about a C-130. It's excessively loud. You have to wear earplugs. Because it's like sitting next to a chainsaw or a lawnmower for 9 hours. It's a 9-hour flight from Christchurch, New Zealand to McMurdo. So, and even driving in these things are very loud, so you have to wear ear gear. Otherwise, you'll lose your ears. This is where I stayed. This is the small dormitory where I stayed. Mammoth Mountain, and they actually gave it a name. No foundation. Nothing's got a foundation there, right?
Doesn't look stable.
No, it doesn't. But a lot of these are still on skids, from skis. They just push them in, and that's it. I mean, there's several permanent buildings in McMurdo. It's a very big place.
Is there any dirt?
Oh, well, yeah, you'll see. There's dirt. Not quite like the dirt that's here. This is what I had for a room. Bed, foot locker, that's it. But this is the view out my window. And of course, the mountains across the Sound and Shore Road with this day when it's in the picture, but you can see I sat next to the helicopter pad. And so from 6 a.m. until 10 p.m. every day, I would listen to helos. This year, most of the Hueys nowadays have got bells and Hueys that take scientists into the field. And we take the same route too, to go and service our weather stations that are close to McMurdo. Here is a picture of the station, and it's quite big. It's grown up a lot. In fact, it's even grown up since I've taken this picture some. This is the largest station on the entire Antarctica. It hosts about 1,000 people in the summertime and about 200 at this time of year in their winter. I stayed here, and I worked in this beautiful, brand new science lab that the United States finished building a few years back, about 10 years back, and it's been a wonderful place to do work. How am I going to keep warm? And how am I going to have power? This is how we do it, and it's with fuel. They have quite a bit of fuel caches to fuel diesel generators to keep the station heated and powered, and to refuel the aircraft that are flying in and around the continent. So fuel is really critical. Antarctica is a nuclear-free zone. The United States used to have a nuclear power plant at one time here. We used to use RTG, thermal, nuclear devices to power those. They're wonderful because they power forever. But Antarctica is a nuclear-free continent. In fact, when they took out one of our weather stations in a remote area in 95, the Antarctica continent is now nuclear-free. So this is how it's done.
Good place for wind farms, all right?
Well, it's very interesting. We've never been really in favor of wind farms in our group and powering these things, because if you lose those props, now you're in trouble. You have no chance of powering anything, because some places the wind is so strong it'll take prop away. So there are some groups who do power their science equipment with wind. Wind's a possibility, yes, no question about it, but the maintenance really compared to solar is an interesting issue. And solar, of course, is wonderful for only half the year. Right. This time of year, it's dark all the time, and solar doesn't do any good. So, for us, it's no problem. Solar panel charges those batteries for 6 months of the year. The 6 months of the year can run off batteries.
But I mean, all that diesel.
Yep.
Wind farm, what the heck?
I don't know. It's an
Heavy-duty wind.
interesting possibility. McMurdo is on this Ross Island. It's a little island that's right off the edge of the continent on the ice shelf. And the center of the island, there is the southernmost active volcano in the world, Mount Erebus. In fact, one of the permanent science groups in that science building where we have a permanent office is the Mount Erebus Observatory. They actually have seismographs and they study this active volcano. Very nice.
They still burn trash in the crater like they did quite a while ago?
No, no more burning of trash. Open burning of trash is no longer an accepted practice. In fact, it's an interesting point. In the U.S. Antarctic program at all stations, everything is recycled. When you go to throw something away here in the U.S., what have you got? One trash bucket and one recycle bucket, right? In Antarctica, you have 16 buckets to throw away things into. You separate your trash at source. Brown glass in one, construction debris in another, burnables in another, etc.
They have a sewage treatment plant?
No, they don't have a sewage treatment plant. That is one thing that's kind of left fuzzy.
They take all this stuff back?
If you're at a field camp, you go camping out here, everything comes back. Even the big 55-gallon drum that you use for the trees, that comes back too. But at McMurdo, no. That's
No
one
peeing
thing.
in the snow or anything?
Well, they kind of sort of, yeah, it's an interesting question. There are places where they have flags, they flag routes on the snow where it's safe to go. You know, red and green are safe, black is not safe, and yellow, well, that's exactly the yellow flag.
You can pee in with a yellow flag?
Sure. But yeah, for the most part, the U.S. Antarctic program recycles 72% of its waste stream. The United States, on average, does what, 20, 25% at most? And that's what the U.S. program does.
But how about the penguins and stuff? They're allowed to do whatever they do.
It's their content, right?
That's not fair.
Asking about dirt. What do we see in this picture? See any trees? See any grass? Nothing but rocks. If Antarctica melts, where it does melt, this is what it looks like. There are exceptions. You mentioned there is on the banana belt of Antarctica, I like to call it the peninsula banana belt. It does get grasses and a little bit of grasses. There are lichens, but that's about it. This is what it looks like. It's igneous rock. And geologically speaking, it's very new, right, in this part of the world. So that's what it looks like.
Were there tropical plants down there a long time ago?
Fossils are a whole different subject. You bet. There's all kinds of interesting tropical fossils.
Dinosaurs used to roam there?
You bet. All that's been found. In fact, there's a lot of geologists who spend a lot of time in the Ellsworth Mountains, up here in the Grosvenor Mountains. A lot of time going. Like all the rock pickers, as we like to call them, geologists, go off and find all the fossils. And there are an awful lot of them. And they do show that Antarctica at one time did have tropical forests on it and dinosaurs and all kinds of interesting things. Sure, you bet. Here we are working on a weather station. This is one that we need to raise up. You can see the enclosures right at the ground. You can stand right on it next to it. So this is what we do. We actually put up, as I was mentioning, we put up another tower section and raise the instruments up because the stations do eventually get buried over time with accumulation. The front door to the lab I work in. Has anyone worked here on a farm or at a supermarket where they have big walk-in freezers with a big freezer door? Anyone done that? This is the front door. It's a big, huge walk-in freezer door. And it's not to keep the cold in, but to keep the cold out. Here is the Mount Erebus Observatory, and there's seismographs. In fact, I took this picture when there was an earthquake. It's kind of fun. I couldn't feel it. I didn't notice it, but their seismographs sure as heck picked it up. So a lot of interesting science and other disciplines does go on. Our weather station lab, and you can see it's kind of a disorganized mess with crates where we have all weather stations, and you can see the aero vanes all lined up where they can be used, antennas to collect data, put on weather stations, and so forth. And if you ever talk to me while I'm in Antarctica, grab my business card, send me an email, this is where I am. My office, it's not very large, it's kind of small, but a couple of computers, and that's where I am, processing the weather satellite data, getting the weather station data, working with the weather forecasters, and other non-meteorology scientists who need our weather data to do their research. And here's an example of, I'm giving a lecture not much different than this one here, showing some other scientists here. In fact, there's a glaciology guy, there's a fellow who's interested in doing geophysics work, and a fellow who does studies of the volcanoes, and a guy who launches big balloons. So I help them out do their work. Yes.
How hot does it get there? What's like the max?
Well, we've had weather stations on the peninsula and along this coast that get up into the 50-degree Fahrenheit range,
Wow,
believe it or not.
nice.
It does get to be nice here. McMurdo has broached above freezing. It gets into the almost 40, not quite, but they have had some nice weather there.
Go out and play
But it
basketball
never
or
gets
something?
above freezing at South Pole, for example.
Do people go out and play basketball and stuff?
When the temperature gets above 0 degrees Fahrenheit, the fish biologists come out in their shorts. So there you go. Everyone asks me, have you seen a penguin? There's one I've seen. I until 2000, I went down in January 2000. The 3 trips before that, I went in November. And the ice is still in and it's part of the continent, so there's no penguins. So this is one I had seen until then. And then when I did go there in January 2000, way off in the distance, little penguins in the distance, and I didn't get a good picture, so there's my one penguin picture. Now, with the exception of the smudge on this side of the slide, look at all these funny things back here. What the heck are those? Anyone want to take a guess? You want to take a guess? Elephant seals. We got any other guesses? What do you think? Rocks. Rocks? What else? Any other guesses?
Meteorite?
Meteorites? Well, that's a very interesting topic. I'm glad you brought that. You're pretty close. And it does look like rocks, doesn't it? These are seals, and they're actually leopard seals. And they're big.
They're what?
You know, they're like this row long big. They're out there sunning themselves. And you don't get terribly close to them because they would like you for lunch. I'm sorry, these are leopard seals, yeah. Yeah, yeah, truly, yeah. I went out cross country
This
skiing
guy
one
went
day.
down there, they went and saw the seals. That was part of the trip.
Oh, yeah, you gotta do that, yeah. So this was kind of interesting running into these. And of course, underneath the ice, when you get into the water below the sound, there's an awful lot of wildlife, fish. And these fish are interesting because they live in an environment that's so cold, it's full of ice crystals. Wisconsin fish, when they live below the ice, it's not full of ice crystals, they do very well. They would freeze in this environment because the ice crystals would attach to their body and they would freeze to death. But these fish have antifreeze. In fact, there's a researcher studying that antifreeze. How do they do that? That's a really interesting area of research.
And they're bioengineer people with that stuff so we can withstand cold weather.
I don't know.
So scientists down there bioengineered with that kind of stuff.
I don't know. As you can see, if you take a look at this one,
They
it's
save a lot of money on clothes.
I don't know. It's amazing the wildlife that's down there. Starfish, sea anemones. If you look at the next one, we've got octopus. You know, there's all these little fish with these curly tails. I mean, there's all kinds of interesting little creatures that are there. So there's an awful. In fact, that's one of the more interesting things that does take place in the art. The sponges that live in the bottom of the sound, they produce chemicals to make them taste bad so the fish don't eat them. Well, it turns out that those chemicals turn out to be inspiration for chemotherapies to cure cancer. Well, so there's a group of guys who spend half their year diving here that go collect these little sample chemicals so that they can go simulate synthetic ones in the lab that aren't as toxic because they're kill you, they're toxic to humans. So they can develop better chemotherapy. Then they spend the other half of the year doing the same thing off of Hawaii. So what a life. Half the year in Hawaii, half the year. And you know, that's really critical work. You know, that's pretty important, you know, health-wise. Yes?
What is Lake Vostok?
Ah, Lake Vostok. Oh, that's an interesting question. At Vostok Station, the Russians drilled a ice core. And that ice core was 3.3 kilometers deep when they got done. The Russians and the French and the U.S. finished the last 0.3 kilometers. And underneath this part of the continent, there's a glacial lake sitting underneath that 3 kilometers of ice. And so Lake Vostok is an underground lake in this area. And actually it's been a very hot area of controversy in the science community about how do we go and sample that lake without contaminating it. The evil thing about ice cores, when they drilled the ice core of Vostok, and they probably do this in a lot of other ones, to keep the ice, the core, the entire depth down. So they only drill out 3-meter sections at a time. The rest of it is filled with kerosene to keep it open. And so, like, well, we can't use that as a way to get into it because they'll pollute it. They don't want to do that. And even if they drill a new hole, they want to do it so that they don't introduce any organisms to kill whatever may be living there. We don't know. We have no idea. We've never explored that lake. There's apparently some others too. I don't know very much about them, but that is a big deal. And I don't know where the science community is at this point with Lake Vostok, but it is a hot topic and it is one that is being actively discussed. And it may be figured out and planned, but I'm not sure. They've been doing some tests at South Pole, hot water drills, and some of them are starting at the University of Wisconsin, and some of them are involving trying out some techniques that could be used at Vostok. I don't know.
Related to the Europa, you know, the whole connection with Europa about
Oh, yeah.
do something.
Yeah, I'm not sure because there's a lot to it, right? There's a lot of big deals about comparing it. Yeah, oh, that's a lot like what you see Europa, right? But I don't know much about how. It's been a big debate about how to do that right without screwing it up, and that's the big challenge.
Do the fish guys expect to find marine life?
I don't know, but I think there's an expectation that the microbiologists want to see, hope to see something new. I think that's where it's at, would be my guess. Because this is a landlocked area. I mean, yeah, if you melted all the continent in theory is mostly below sea level, but the continent has got so much ice on it, it's heavy and it's pushed the continent down, you would have the continent would rebound and come up above sea level if it actually melted. So there's no actual, it's an interior lake and it's completely beneath this huge, thick ice cap.
So how big is the lake? Really big?
I don't know. I don't remember the map details, and I'm not so sure that they know, to be honest. But it's roughly an area, a fairly sizable area around Lake Station.
Did they find it by accident or were they?
I don't know how that was found. They may have, but I'm not sure. I don't know if that was done because a lot of surveying in glaciology where they actually can do active remote sensing from above, looking down through the ice, you know, with a sensor and getting back some information. And
So
they
you
may
got
have
some
found it remotely.
Geothermal stuff
I don't know.
underneath it? That's the one.
I'm not sure. This is where it's beyond. As a meteorologist, I don't know. Good question. So, is this a picture you think you'd see in Antarctica? Something green with a flower on it?
We need a greenhouse.
Exactly. This is a greenhouse. They do have one at McMurdo. If you take a look at the next picture, you can see that hydroponically they do grow a little bit of food, you know, for eating. That's about all that's really permitted. Introduction of foreign flora and fauna is not at all permitted by the Antarctic Treaty. It's really dangerous to the delicate wildlife that's there. And I wanted to close the slides with a couple from the historic huts in the Antarctic. This is Scott's first hut that he built in 1901 in his first trip down. I get a giggle out of it. He built the hut based on the Australian outback huts, which of course were built for what, the heat. Going on the cold, and he built these huts where they froze to death. But they're preserved. Take a look at the next. This is the same way it almost looked, other than a little bit of weathering when Scott was there. It's not changed. I can walk down to this, you know, it's a 10-minute walk from my office at McMurdo to go see it right on the point. I had the pleasure of taking a trip one year to Cape Evans. It's up a little ways. It's about an hour drive if the ice is still in to go to Cape Evans, where Scott launched his trip to South Pole, his fatal trip to South Pole. And this is what it looks like that way. Also not much different than the one he built at the other location. And everything that was in that hut is still there from when they were last there. Skis, axes, pickaxes, buckets, shovels, it's all there. And all their food. Biscuits. I got a bottle of Heinz ketchup. Frozen. And most of it in good eating condition. No freezer burn. It's all still there.
When was he there?
This was 1911, 1912, that there was a group here. And then, of course, it's been maintained by a historic society, keeping the site up. You know, you can go in, you can take pictures, don't touch anything is the rules and so forth. But they've been trying to keep the sites maintained. There's several historic huts around the country. And of course, I like to close with my cold weather strip of Antarctica, just to stop here. So, anyways, feel free to come and look at the weather station, cold weather gear, or the map. If you got any questions, come see me. But otherwise, thank you for your attention.
Matt?